Hello everyone, this is Dr. Song. Welcome to my YouTube video. So today we will start the quantitative research method, week 3, part 2. So I will talk about the standard deviation. That concept is very crucial for quantitative research method. So first, these references are important for my course. I constructed my course based on the 3 courses, and then these are the names of my professors. So, why we care about the standard deviation? Maybe you heard about this concept. So that is you can see in this graph. When the standard deviation is large, you will see the graph is more like that way. So when it's a mean in the middle value, and then the variability, how much diverse scores in that data, you can see the by this form. So it's a very variability is very great. And then when you see that, it's a very like a peak, like the mountain, like a mountain. That form means that the mean score is here in the middle, but you can see that the variability is very small. So that means that every score is very close to the mean. So that is a less variability. So you can think about the standard deviation means that how much the scores are deviated from the mean score. So when the standard deviation is small, that is data points are close to the mean, as I explained. And then if the standard deviation is large, that is data points are distant from the mean. So you can see here the samples, we can check about your concept, what you understood. So which sample has the more variability? That means that which one is the high standard deviation. So when you see this, the information, mean score and the standard deviation and the mean score standard deviation, you have to calculate that how much percent the standard deviation represents in this data. So what you can do, you can divide the standard deviation by mean. So standard deviation here is a 15, and then divide by the 100. That is a 0.15, and then you multiply by 100. That is the 15%. So you can say that this variability, the level is a 15%. And now let's see the second one. Standard deviation is 5, and then divide by the 10. That is a 0.5, and then multiply by the 100 is a 50%. So now you can confidently say that the second example, this has the more variability. That means that when it's a data is with the mean, they are more like a flat form. And then the first one, number 1, is a 15. That is more this way. Okay, so that means the scores are less variable, and then the number 2, that is the scores are more variable. So this is a standard deviation. So the others you can also calculate by yourself to know the which one has the more variability. But here you can see that the what is the score look like in this sample. Standard deviation is 0. That means that every score has the same value of the mean. So every score is the same 26. And then the third one, more accurate means that if they have the less variability, the mean score is more accurate. So you will also calculate by that practice we did. Okay, so I just explained that when mean is 100, standard deviation is 10, and then you divide by the 10, 100 multiplied by 100, that is a 10%, and then this one is a 30%. That means it's a more variability, so the scores are far away from the mean, and the mean is less accurate. Again, this is the same thing. You can see the like a mountain style that is very close to the mean, and this one is more variable, is a more distant from the mean. So what is the limitation of the sum of squares? So uh, some of the squares I explained last time. So that is I just want to explain this. Okay. So some of squares you saw that when is that is distant from the mean score, you will obtain the square, the number how much they are distant, and then you have a sum, like you add every number, and then that is the sum of squares. So what is the limitation of this? is that they are dependent on the number of scores in the data because you have to divide by the n minus 1. So that is depending on the number of scores in the data, sum of squares. And now what is the limitation of the variance? The variance, that is the square units. So you have to make that as a square root unit. So that is the standard deviation. So the variance, that is just the one step before to obtain the standard deviation. And the standard deviation is the square root of course, there is a variance. I just said that. So you obtain the sum of squares, divide by the n minus 1. N is the total number of the participants. And then you obtain the variance. And the variance, you make a square root. That is the standard deviation. So which of these variables has the least amount of variability? And also you can take the calculation of that standard deviation divided by mean value, and then multiply by 100. So if the percentage is greater, that is the more variability. So here you can find something is a smaller variability. So also this quiz you can check that you are understanding. That is again, most variability means that is distant from the mean. So when you obtain the percentage is higher, that will be the most variability among four. So that is also your case. Now, interpreting the standard deviation to understand more about the concept. So here you can see that that is like a distribution of the data. And then this is the mean value, is a 50. So this group represents the 50 is the mean value, and they are distributed in the normal curve. So that is a normal distribution. That is not skewed. That is not the high and the low kurtosis. So this is a normal distribution. And you can see that from the mean, you have the standard deviation is 1, 2, 3. So that is a standard deviation plus 1, plus 2, plus 3. This part is a minus 1, minus 2, minus 3. So how much they cover from this score data distribution? You can see that the first standard deviation is left to the right. They have the 68%. They're covering the 68% of the scores. Now standard deviation 2, that is the 98% cover the whole the scores. So the right part is 13.5%, left part 13.5%. And then the final is standard deviation 3, that covering the rest of the 2% and the 2%, so there is a 4%. So totally there is a 99.7. And then the second standard deviation area, there is a 95. And then the first standard one area is a 68%. So that is the very clear indication about how you interpret the percentile, standard deviation, and then also that is one example. So here, that is a mean value, 73.5, and then that is becoming is a 11.1 11.1. That is a standard deviation one area. This one is deducted from this score, 11.1. And then you can see the percentile. That is going up, that is going down, but it's the same amount. So 34% is more is 84. 34% less is 16%. So it's very easy to understand. So this one you can see again the same repetition of what I showed. Standard deviation 1 and then 2 and then 3. That is about the 68, 95 and the 99%. So we call that in this area, yeah, when you see the data points where that fall down, we call that z-score. Z-score, you can obtain that standard deviation deducted by the m, and then no, sorry, that is s. So the z-score, yeah, there is a minus m and then divided by sd. So that is the formulation how you can obtain the z-scores. So when you have the z-scores is a 1.96, that means that falls in the 95%. If it's less than that, that is in the inside of the dead area, is a standard deviation 2. When it's over than 1.96, you will consider that there is more than standard deviation 2, that is more than 95%. So this one, we saw that already. And now you can see the more details. So yeah, so that is the again standard deviation and the z-scores. I just said that z-scores minus average and divide by standard deviation, you can obtain that. And then this one is the z-score. That is also standard deviation. Yeah, it's the same thing. So you can consider that z-scores, they are the position of each score, individual score. So when it's higher than the z-score 2, that is more than 95%. And then it's a higher than z-score 3, that means more than 99%. It's a very, very extreme scores is here. That is also considered as how when you detect the outlier, but we will talk about that later. Okay, so that is the descriptive statistics. So you can see that mean value and the standard deviation 1 to 3, and then there is a bell curve. So that is a normal distribution. So in the normal distribution, which of the following statement is true? The mean, the mode, and the median are the same. So this is a good answer. Why? Because there is not skewed. It's not the left or right skewed. And then they have the not a high or too much low. So this is normal distribution. In that case, the mean and the median and the mode, everything is in the same point. So that is a normal distribution. So again, this is the kind of different graph talking about the different standard deviation I explained. Yeah, so you can see that there is a high variability, and then this one is a low variability. So when they are close to the mean, standard deviation is small. So variable with the normal distribution has a mean of 100, and the standard deviation is 10, which is the following statement is definitely true. So there is no variability. That is not true because it's a 10. The range of score is between 0 and the 200. That is not the good answer. 98% of the score for between 80%, 80 and the 120. Yeah, so that is the when you calculate it from the 100, the first standard deviation is 110, and the second one is 120. So that is about the 95%. And then in the left part, there will be the 90 and then the 80. So that is about the area of the 95%. And this one, 75% of the score fall into 4 between the 90 and then the 110. So let's see about this one. So you can see that 75%, that is the second part here. Yeah. So that is, you can see that is a between 900. Yeah, so that is a more than 900 and 110 because it's a standard deviation 2. So that is the correct answer. So this is the one part of the standard deviation I wanted to explain today. And the next time I will explain more about with some practical exercises, and then you can consolidate your concept of the standard deviation. Thank you very much for today, and then see you next time.